we now come to determine the depth factors. Over here, our depth is given as what? 2.4. And our breadth of the foundation is given as 9 meters. So to find df over b, we give us 2.4 divided by 9, which is given as 0.26. So, and after that, we will come to find the depth factors. And the depth factors, we have to find lambda CD. And lambda CD will give us 1 plus 0.2. Then we slot in the formulas, and it's given us 1.10. So then lambda D will always give us the same. Lambda QD is equals to lambda D. That will give us 1 plus 0.1. You also find the theta, the angle there, and also give us 1.05. Then we calculate the ultimate, we calculate the bearing capacity. And the bearing capacity, we use the Mayhoff equation. The Mayhoff equation is given us, yes, okay. And the Mayhoff equation is given us this one. So when you find this one, when you get this calculation, when you finish, you calculate for the ultimate bearing capacity. And the ultimate bearing capacity is given us the bearing capacity times the area, which is given us 1,000. $581.9 divided by 3.0, which is giving us 5,527.3 kilo. Hello? Hello? Yes. Hello. I'm saying that an increase in 47% compared with example 1 in this same solution that, hello? Hello?
Sir, hello?
Hello?
Yes, sir, we
yeah, please. Yes, I'm repeating it. I said an increase in 47% compared with example 1 under this topic, topic from the time that we started. Do you understand that?
Yeah. Yes, sir.
So
yeah.
Then move on. Maybe also same example 1 with load. We are also use the same example 1 with load inclination at 20 degrees Celsius.
Okay.
The inclination factors, where we are using this angle.
Hello, sir.
I'm coming on, please. The inclination factors. For the inclination factors, for theta, we are using this equation 1 minus bracket open alpha degrees over 90 degrees all squared should give us this. Then when the phi is greater than 0, we are also using this equation. When the phi is greater than 0, we are using this. So that is why we got to this point here where we say that So after we determine the inclination factors, then we begin to find the lambda CI equals to the lambda QI. That will give us this equation. That will give us this value. So then we come to find the lambda I. Will also give us this thing. It's on situation where the yeah, on situation where alpha is tilted to what? 20 degrees Celsius. When alpha is tilted to 20 degrees Celsius, that is when you are going to use this. Okay? That's when you are going to use this. So we will have into this where we begin capacity equation to have this, and then we go ahead to calculate the ultimate bearing capacity. Then we find the allowable bearing capacity, and our allowable bearing capacity will give us just the ultimate bearing capacity by top safety, and it's giving us this. So we'll go on and down. Yes.
So can it be a situation where they will not give you the angle, but they will rather give you the NC, the NQ, and the N lambda?
Yeah, there can be a situation like that. There can be a situation where they don't even give you the angle. So you have to use the NCS. They will give you the bearing. They will not even give you the angle, but you'll be asked to calculate for that. There can be a situation like that. Okay?
Okay.
Yes, there can be a situation like that. There can be a situation like that. So what I've given, just go through many of them. So they are just there to help you. There are many. If you say we are going to go to the first. No. Oh, sorry. This is no. It's. Yes. So come back to this. Then we need to go on to. We have to come on to retaining walls. We come to retaining walls. We have lateral earth pressure and retaining walls design. We come to lateral earth pressure and retaining walls design. Lateral earth pressure and retaining wall design. We say 1, we have to determine objective of this chapter 4, to determine